interfaces before we start actually trying to put one of these things in here. Let's talk about this a little bit conceptually first. What is an interface? Somebody just give me a 1 or 2 sentence description of what an interface is in Java. Yeah. It only has methods in it. There's a little bit more to it than that. We're heading in the right direction for sure. You said it's kind of like a class. I think they're pretty different. I mean, you're right about the methods part. If I look in there, am I going to see fully formed methods with all the bells and whistles? No. What am I going to see? Yeah. Yeah, so it does allow different classes to have the same methods, even if the implementations of the methods are different. That's the big thing with interfaces. So what do I actually see in an interface? We're about to create one in a minute, but if I give you an interface and you were to look at it, what are you actually going to see in there? Look in there and I see what? Yeah. Sure, we had actually a name for them in C. Do you remember what they're called in C? Declarations or prototypes. They might look a lot like prototypes, right? We don't call them prototypes in Java. We call them signatures, method signatures, or method declarations, I would say, is also acceptable. It's just basically this, right? It's just basically that first line, and that's it. Anything that comes after this is not going to be in an interface. It's not going to be there, which sounds a little strange at first, right? Sounds a little strange at first. So then we have this interface. It defines these methods. It doesn't tell us how they actually work. It just says this method is here, right? And so then how do I use that interface? How do I actually tell that interface to do something? What do I say? Use the implements keyword, yeah. So up here, we talked about inheritance last time, right? I said extends account. That's for inheritance. I want to use an interface. I say implements and then the name of an interface. And then once I do that, what happens? Once I do that, what happens next? Yeah. Correct. So once I say implements an interface at the top here, I enter into a contract with that interface. I am now contractually bound to implement any of the methods that are defined in that interface. I am responsible for that. It is my job. If I don't, then it's not going to let me run my code. It's going to say, sorry, you said you're using this interface, but I don't see this method in here. I'm not going to let this go. Right? There are some strong advantages to that enforcing that rule, to enforcing that contract. Okay, here are some other questions actually that I have for you that maybe weren't necessarily on the video that I posted, but were in other resources that I posted. Can I put things other than methods inside of an interface? Anybody find anything about that? So what other things might there be? If it's not a method, what might I be talking about? What else do we find in classes? Fields, right? So can I put those in an interface? What do you think? You actually can. I believe I linked to the Java documentation on interfaces. They gave an example of where they have a field in there as well. So I can require that certain fields are present inside of my classes as well through interfaces. So I can put fields in there. More often you're going to see methods. You're not going to see fields appear as often, but you can put them in there. More often you're going to see methods appear. What's the difference between using an interface and using inheritance? So that's really a big distinction. It's a good one to know. This is going to be, I mean, you talk about interview questions. Describing the difference between using an interface and using inheritance is a classic interview question for somebody. Yeah. Mm-hmm. Right, you're exactly right. So with inheritance, I'm getting the entire method. The method exists, and I get all of it. I get the whole thing. Whenever I inherit from the account class, any method that's in the account class, I now have that whole thing, implementation and all, right? With inheritance, I'm not getting an implementation, you know, and instead I'm entering into a contract that says this method needs to exist. I don't care how it works, right? You can decide how it works. It just needs to be there. It just has to exist. Is there another hand I saw? Yeah. Mm-hmm. Mm-hmm. Yeah, so inheritance really allows us to exploit code reuse. I can reuse the same code over and over again. We saw that actually last time when we had this withdrawal method that was kind of different, but we could reuse the code that we had in our base class, right? With inheritance, we can't do that. We're not inheriting a fully formed method. We're inheriting nothing. We're being required to implement a method from scratch, right? So there's nothing that I can use as a basis like I have with inheritance. Up here at the top, when I specify, you know, that I'm using inheritance, or I specify that I'm using an interface here, can I use both? Can I put inheritance and an interface here? Yeah, actually I can. I can implement interfaces and use inheritance all in the same class. Can I implement multiple interfaces in the same class? Yes, absolutely can. What about inheritance? Can I inherit from multiple? No, you cannot. You can only inherit from one thing. Does that make sense why that restriction exists? Why can I only inherit from one thing, but I can implement from many different things? What's the pitfall of inheriting from multiple objects, multiple classes? Yeah. Yeah. The diamond problem is the classic name for it. If I have the same method implemented in two classes and I inherit from both of them, which one do I use? Which one do I use? With inheritance, that's not a problem because with an interface, that's not a problem because there's no implementation, right? There's no implementation. There's just the requirement that a method exists. With inheritance, I have an implementation, so if I inherit two different methods with the same name, I don't know which one to pick. I no longer know which one to use. Yeah. So by convention, inheritance always comes first. I don't know if you could switch it around or not. I've never tried it. Never actually tried it. But I know by convention, inheritance happens first, and then the interfaces happen afterwards. So what then is the relationship with inheritance? What was the relationship with inheritance? We used what kind of relationship? Is a, right? So I say something is something else. That's an inheritance relationship. What's the relationship we use for interfaces? Can do, right? Can do, or can be, I guess, was another suggestion. I agree with that suggestion as well. So in this case, think about the difference between those relationships, right? With inheritance, we're saying a thing is the same as this other thing. So we're talking about nouns. Right? We're talking about physical objects that exist that are the same in some ways, not always, but in some ways. With interfaces, we're talking about behaviors. This thing can do these behaviors. This other thing can also do these behaviors. They might not behave exactly the same, but they can do them, right? So we're grouping things by verbs, by behaviors, and that's why you usually see what part of speech used as an interface? Adverb, because we're all very fond of the English language around here. English is not my strong suit, but I actually learned English better through programming language, believe it or not. It helped me a lot. Okay, I think that's enough conceptual review. Let's actually start to create one of these things. So what I want to do is actually talk about something that we did last time, which is compounding interest. We implemented this compound interest method last time. We used the standard formula, right? There's actually another way that we can use to compound interest. We can compound it continuously. And the formula for that is different than the traditional interest formula that we use. So we have a choice here. Do I want to compound continuously, or do I want to compound using the traditional formula that we did last time? I want to use an interface to implement something called the strategy pattern. I talk about this pattern in the studio for today, right? So I thought it would be really important to go through this pattern with you in class. So what I want to do then is define an interface, right, that's going to be very simple actually. The interfaces themselves are usually pretty easy to put together. The interfaces themselves are usually pretty simple. The interface is going to have one behavior in it, this compound interest behavior, right? And then I want to implement that interface in two different ways. One way using this traditional formula, and another way using the continuous compounding formula. They're actually not that different. They're pretty similar, right? But a good example for this. And then I'll show you how to use the strategy pattern to implement one of those over the other. So let's start out with the interface. I'm going to right-click and go to New, and this time I'll select Interface from the list here. What might a good name for this interface be? We're going to use it to talk about compounding interest. So, sticking with the conventions for interface names, what might I choose? Any ideas? What about just turning that into, so compound is a verb, right? What about turning that into an adverb? That would be compoundable, right? Sticking that able on the end turns it into an adverb. And interface names are most often going to be adverbs. Compoundable. All right, I'm going to go ahead and click Finish. Here's my interface. There's really only one behavior that I care about in here, and I want it to be able to compound interest. That's all I really care about. I want it to be able to compound interest, right? So I need to start forming a signature. We have this signature that exists already in my savings account class, compound interest. However, I can't use this as is. Why not? I'm sorry? The fact that it doesn't return anything is not going to hurt us here. There's another reason why we can't use this signature as is. It's because of the parameter, right? More specifically, it's because when I compound continuously, the number of periods doesn't matter. It doesn't exist. There are no periods. I'm compounding continuously. So in order for me to define this in my interface, I need to have a consistent method here. I can't have one that sometimes uses a parameter and one that sometimes doesn't use a parameter. It has to be the same for both. So I'm going to borrow this signature, but I'm going to take the parameter out. And that's actually okay. We'll actually need the number of periods, but I'll show you how we can actually enforce that a little bit later. Just a minute ago, I suggested that we could actually put fields inside of this interface as well. Can you think of any fields that we might want to require for compounding interest? Yeah. The interest rate. The interest rate's a good one, right? If I need an interest rate regardless of the method that I choose. I realize all of us might not be that familiar with the compounding interest formulas, and that's okay. I actually have them pulled up on a different tab because I don't remember them either. But we do need an interest rate. No matter how we do it, we need the interest rate. So we could require that interest rate. In fact, previously you saw we had that interest rate set as a field within my savings account class. Well, this is a design decision that we have now, right? This is a design decision that we have now. Do I want to keep this interest rate here, or do I want to require it as part of the interface? I don't think either way is necessarily wrong. I don't think either way is necessarily the wrong way to do it. The question we need to ask ourselves is, am I ever going to want to ask this savings account for this interest rate? Or is it okay if I always go through the interface? That's the question that we have to ask ourselves. I realize, yeah. Yes, the interface would require me to create that field whenever I implement it. Yeah, so here's the trick here. I'm actually not going to implement this interface on savings account directly. The strategy pattern says I do it a little bit differently than that. So if I was planning to just say implements compoundable here, then it wouldn't be a problem, right? It wouldn't be a problem because I could just include that field as necessary, but this is actually not what I'm planning to do. I'm planning to steer us in a slightly different direction. So I'll tell you what, right now I'm actually just going to leave this as is, and maybe later we'll revisit this idea and talk about the pros and cons of doing it differently. For now, I'm just going to keep it very simple. I'm just going to use this method, compound interest. That's it. So the big thing, one of the major takeaways that I want you to get out of this presentation, besides interfaces and how to use them, is this idea of the strategy pattern. I realize that most, if not all of you, maybe not have seen the strategy pattern yet. So the next piece of the strategy pattern that we need to talk about is this idea of creating strategies. I've talked about two strategies for compounding interest here: continuous compounding and non-continuous compounding of interest. What I want to do is create two different strategies that implement this interface, right? And then each one will implement this interface according to the formula that we want, the two formulas that we want to use. What part of speech is a strategy? Strategy is in this context, from the English language. If I look it up in the dictionary, it's going to say strategy. Part of speech is, what? It's a noun. It's a noun, right? So with that in mind, in Java, nouns become one of two things. What are those two things? Objects and what's the second one? Fields, right? Nouns become objects or fields. In this case, I'm going to choose the first one. I'm going to take this strategy and turn it into an object. I'm going to create two of them, actually. So let me create the first one. We'll do the non-continuous compounding first. So I'm going to go up here and I'm going to say new class. I'll say non-continuous strategy. And I'm going to go ahead and click finish. And what I want to do then is have this class implement the interface that we just created. That's what I want. That's what I want to happen here. Okay? So the first thing I need to do, I believe we already talked about this, is say implements, if I spell it properly, compoundable. Oh. Implements compoundable. As soon as I do that, you see it's angry at me. Why is it angry at me? Why is it mad at me? I haven't implemented the methods, so as soon as I type this in, I enter a contract between me and the interface that says I have to implement the methods that that interface contains. And because I haven't done that yet, it's angry at me. It's mad at me. So what I can actually do to save myself a little bit of time, Eclipse will look at that interface and give me a head start. So if I click the little light bulb over here, whoops, yeah, down here at the bottom it says Add Unimplemented Methods. So I'm going to click that, and what happened? Oh, I just need to save this file first. Sorry. I forgot to save my interface. Let me try that again now. Add unimplemented methods, and boom, it generates the methods for my interface for me, and now all I have to do is fill in the implementation. Right? Okay. So I want to, for my first implementation, I'm just going to do it exactly the same way that I've got over here. In fact, to start us off, I'm just going to take this code that we've got over here, and I know last time I talked about how much I hate to do this because it makes me gag. But I'm just going to copy it in. This time it's okay because eventually we're going to go back and delete that other version. Right? So this time it's actually okay. I'm just going to come over here and copy it in. Right? Copy it in like this. And you see that I've got some problems. The interest rate doesn't exist. Number of periods doesn't exist. Balance doesn't exist, right? I can't get to this dot balance. Doesn't exist. Doesn't exist. So how am I going to reconcile some of these problems? Well, there's one big thing that I'm missing here that can help me with some of this stuff. Every class should have a constructor, and I don't have one yet. So I can use that to help me alleviate some of these problems, right? So let me create a constructor next. Public non-continuous strategy. Right? So I can use some of these. To help me out here. For example, the periods. I could certainly take that in. What did I use that as last time? Was that an integer? It was. It was an integer. So I'm going to stick that in for sure. Right. What about the interest rate? The interest rate already exists, correct? The interest rate already exists, right? So do I want to take it in as a parameter then? What does that imply? Getting into some interesting design territory here. Interesting design territory. Kind of goes back to that question that I talked about earlier. Do I want to require this as part of my interface, or do I want this to remain in my class? Right? Let me let you think about that one for a second. Let's go back to periods. What am I going to do with this parameter? What should I do with it? What do we usually do when I take in parameters to constructors like this? I usually say something like this. This dot periods equals periods, right? But I don't have this yet. But I can put it in. This is a class, right? Private int periods. So now that I've finished that up, let's go back to the interest rate. Do I want to do the same thing that I did with periods just now with the interest rate? What do you guys think? Or do I want to use the interest rate that I've already got over here? What do you think? What do you think? Any ideas? Here's a question. Is there any way for me to access this interest rate, this one that I have in my savings account class? Is there any way for me to access this within this class here? Any possible way? Yeah. Could I use a getter? In order for me to use a getter, what do I need? In order for me to use that getter, something like get interest rate, what would I need? I need an object. Do I have an object here? I don't. Yeah. Okay, so the suggestion was if I extend savings account. So let's think about this one for a second. What's the relationship with inheritance? Is the relationship, right? So my question to you is a non-continuous strategy a savings account? Or the other way around, right? It's not. It's not a savings account. So could we use this to get access to the balance? Yes. Could we use this to get access to the interest rate? Yes. Yes, we could. I think from a design perspective, that's a bad idea. Because what else am I getting? I'm getting all of this other stuff that I don't need for my strategy. My strategy doesn't care about max withdrawals, current withdrawals. Doesn't care about withdrawing at all, right? Doesn't care about any of that stuff. All it's trying to do is compound interest. That's all it's trying to do. So it doesn't need any of that stuff. So we'd be giving it extra that's not required for its job. Where is my, here it is. So I don't think inheritance is the answer here. In fact, I'm glad you suggested that, because I would like to strongly recommend that you resist the urge for inheritance as much as possible, especially if you can't use that as a relationship between the two objects. Okay, so then how do we fix this? Well, we can use some tricks to our advantage. For starters, the interest rate, right? Requiring the interest rate as a field inside of this object, I think, is the solution to that problem. Absolutely. I think the interest rate should be included as a field here. So what did I say that was a double? Double. All right? Double interest rate. And that means then, since this is now a field, my constructor must set that to a value. I can take that in from the constructor. Double interest rate. All right, so that solves that problem, but I still have the problem of the balance, and this is maybe the trickiest one of all. And I'll tell you what we're going to do. I'm going to leave it. I'm going to leave it for now. I'm going to move on and hope that a solution presents itself to us as we proceed. Because it will. Let me finish this up first. This dot interest rate equals interest rate. Okay. So I realize this is unsatisfying. I promise you. I promise. We still got almost an hour left. I promise you we're going to fix this before we're done here today. But for now I'm going to move on and explain the rest of the strategy pattern because I think the solution will make sense once we do that. So the next piece of the strategy pattern would actually be to do this over again. I want to implement this on a different object, right? Using the continuous strategy. I would like to do that today. I hope we'll do that in a little bit. But I'm going to skip that step and go to the next step, which then says, go to the class that you want to use a particular strategy. In this particular case, we want that to be their savings account class. The savings account is the one that's compounding the interest. The savings account is the one that needs to either compound it continuously or non-continuously, right? So what we're going to do then is create a field, and the type of this field is going to be the name of our interface. So let's talk about this for a second. When I define a class, you've probably heard me refer to this as saying I'm defining what? What do I say? I'm actually defining a rhymes with I'm defining a type. Exactly. I'm defining a type. Same thing's true for an interface. I'm actually defining a type. This goes back to one of the concepts that we talked about last time as well, this idea of polymorphism. So the strategy pattern says, create a field that has this type. Then I need to somehow set this field, right? It's now my responsibility to set this field to be something that implements this compoundable interface. So we can do that either through the constructor, like so, okay? And then just add a line in, like we've done so many times before. Interest strategy equals strategy. Okay. So we've done that before many times. There's nothing a whole lot new there. And now, here comes the best part. For compound interest, right, I have this strategy. And I know for a fact, because I've said that this strategy is a compoundable object, right, I know for a fact that it implements the compoundable interface. And therefore, I know for a fact that this object will have what as a part of its definition? What do I know for certain this is going to have? Is there some kind of contract that we entered that guarantees certain things that exist? I know it's going to have what? Yes? I know for a fact it's going to have a method called compound interest. I know that because that is how the interface contract works. I don't know how that method's implemented. I don't know whether it's a continuous strategy. I don't know whether it's a non-continuous strategy. I don't care. The savings account does not care. It does not care. What I do care about is the fact that that method exists. So when I come down here to compound interest, what I want to do now is use that method, use that strategy that I know exists. I want to say strategy dot compound interest. Oh, I'm sorry. I did this incorrectly. This dot interest strategy equals compound interest, if I can spell it properly. My apologies. I'm going to call this method. I know that it exists because I know that it's implemented this interface, and I know that because it's implemented that interface, it must have an implementation for that method. I don't know how the method works. I don't care how the method works. It doesn't matter to me. But wait a second. There's a couple things here. One, I've still got this int periods here. What do I do with that? I delete it. If I need to access periods, where does that happen? Where does that happen now? That happens inside my strategy. My strategy takes care of all that stuff. My strategy handles the periods. My strategy handles the interest rate. It takes care of all that stuff. I don't need it anymore. I don't need it. Okay? What about the balance? This was unsatisfying last time. But now that we have this implemented, I think maybe we can do something with this balance, right? Maybe we can do something with it. How can I use this mechanism to help me update the balance? I could pass parameters if I wanted to. My interface, though, doesn't accept, if I go to my interface, you see it doesn't accept any parameters. But I created this thing, right? So I can make it behave how I want. Yeah. We're moving in the right direction. We're moving in the right direction. You're getting there. So if I go to, say, the suggestion was if I go to this guy, where is it? My strategy, can I just take this, right, and copy it back into the base class? We're getting close. We are getting very close. Where am I here? We're getting very close. Well, for starters, this R over N value, I don't have it because that was computed inside of the method. But also, consider this. This method, in order for me to compound the interest properly, I need to know what my balance is, right? I can't compound the interest properly without knowing what my balance is. Yeah, so what does it return? Great question. Right now, it returns nothing. It doesn't take any parameters in, and it doesn't return anything. But remember, we created this. So if we don't like that, we can change it. All right. Yes, you nailed it. We need to return something here. We need to return a value, right? So what data type should that value be that we're returning, most likely? Double. Since we're dealing with money, double makes sense. I think we should take this one step farther. I can't compound the interest effectively unless I know what my balance is, right? So maybe I should pass my balance in as a parameter so that it can do its job, right? So then what I can do is require double balance as an input parameter. Okay, now we're in business. I hope you see how this helps us. What I can do now, when I change the contract, right, I just changed the contract. So if I go over here to my strategy that implements this interface, you can see it's mad at me. It's mad at me again because I changed the terms of the contract. If this was a law contract, we'd be getting sued right now. But it's not. It's code. So I changed the contract, and I have to update this to meet the new terms, right? I have to make this match the contract. So I'm going to say double as my return type, and then double balance as my input parameter. does, why are you mad at me? It does return, oh, it's mad at me because we're not returning anything. So let's fix that. I'm going to actually come back over here and grab this line. I'm going to grab this line and put it back, but I need to change a couple things. This dot balance now becomes what? I don't have a this dot balance. It becomes just balance. I want to use the parameter, right? Same thing for get balance, right? That's just my balance. And then what am I going to return? I got to return a double. I'm going to return the balance. So I return my balance. This works a little bit better for us. And now when I come back over here, right? When I come back over here, when I say compound interest, I have to call this method appropriately. I have to give it an input parameter. What am I going to give it as my input parameter? This dot, either get balance or balance, either way. I guess I'll use get balance, that's fine. And then what am I going to do with the result? What am I going to do with the return value? How do I make sure that I actually update my balance? This dot balance equals, and we are finished. Let me pause. Let me pause here and see if there are any questions about what we've done. We created an interface. We didn't do it right the first time, right? I led us into a trap. Sorry, not sorry. We implemented this interface on a strategy, right? Created a constructor for our strategy. Came over to our savings account class and added in this field for our strategy object, and then use this strategy when we try to compound the interest now. And when we did that, we said, oh, shoot, we didn't create this interface right the first time. Let's just go change it to do what we needed to do. Yes? Sure. Absolutely. So I skipped a step. I really want to implement a second strategy, because that's really going to show us why this is useful, why the strategy pattern is particularly useful. But before we do that, are there any questions about what we've done so far? Anything that I can re-explain over again? Yes? Oh, good call. Up here, right, this interest rate, we're not using it anymore, right? So I can get rid of that. I can get rid of this. Right? I can get rid of this. Good call. We don't need that stuff anymore. Thank you. Savings account does not have an interest rate. The interest rate is now based on the strategy. Yes. There's a downside to that, which is what if I wanted to ask what the interest rate is for a particular account? I'd have to go through the strategy to get it. So just because an interface says I have to implement certain methods doesn't mean those are the only methods that I can implement, right? If I come back over here and I want to create a get interest rate method inside of this class, I can. The interface doesn't care. The interface only cares about the methods that it contains. If there are extra things there, that's fine. It's no problem. What I want to do next is actually do this over again with our continuous strategy. So I'm going to repeat this process. I'm going to go make a new class. This time I'll call it continuous strategy. And just like I did last time, I'm going to implement the interface. Implements compoundable. It's mad at me because I haven't fulfilled the contract. So I need to add in those unimplemented methods. Right? I also need an interest rate here, right? I always need an interest rate. I don't need periods, though, for this strategy. In fact, let me show you this equation, because I don't remember this equation either, and we need it. Here's the equation for continuous compounding. So it's C, that's our current balance. E is a constant, that's Euler's number. It's 2.71, somewhere in that ballpark. I don't remember the exact value. R is the interest rate, and then T is years, yeah, years, right? Which, for our purposes last time, didn't we leave that off? I can't remember how we did it last time. Can't remember how we did it last time. Let me double check real quick. Oh, I'm sorry, that's in this interest rate periods. Yeah. We'll just assume that T is 1, just to simplify the equation a bit for us. We'll just assume that it's 1, just to make things a little easier on us. So all I need is the interest rate for this one. That's the only thing that I need here. I do need a constructor, just like I needed a constructor last time. But this time, all I have to worry about is the interest rate. And now I just have to figure out how to implement this. Now I just have to figure out how to implement this. I want to use this equation. It's actually not that bad. I've got the balance times e to the interest rate. So the biggest question here is, how the heck do I get the value of e out? I would really prefer not to have to type in 2.71. Thankfully, for constants like this that are used frequently, they're usually available to us somewhere in a library so that I don't have to remember what the actual number is. Same thing for pi, right? Pi is such a commonly used value that it's usually stored somewhere for us. I don't have to remember all the digits of pi. Any ideas where I might find this value of e? Math, yeah, absolutely. So let's see what we can do. I want to return balance times, and then let's see what's inside of the math library. Oh, hey, look, there's a value called e right there. There's a value called e right up at the top. And if I look at it, it says the base of natural logarithms. That is, in fact, Euler's number. That's the one that we want. That is the value we're looking for. But I need to say e to the r. So how did I do exponents? Math.pow, and then I say math.e, and then the power that I want is the interest rate. So this is actually a lot simpler than the other one. Because it's continuous, some of the terms drop out. It makes it a little bit of a simpler equation. And my strategy is now finished. But here's the best part. Here's the best part, right? My savings account class is already set up to use this strategy. It's already set up. I don't have to do anything to it to make it work, right? I don't have to do anything to it. The interface allows us to treat this strategy exactly the same as the other strategy. That is the great thing about interfaces. Because I know that the methods are defined the same way, I don't care what they do on the inside. They can do whatever they want to, right? I use the method from the strategy, right? And it just goes off and computes it, and then comes back with the answer. So I guess the one missing piece then is, we actually need to create one of these strategies and pass it into a savings account. So maybe we could, to wrap up our section on interfaces, maybe we could try that out a little bit. I'm going to create a simple main method down here at the bottom to test out our strategies. So I want to create two accounts. I want one account to use my continuous strategy. I want the other account to use my non-continuous strategy, right? The way that I set it up, that strategy is being passed in as a parameter to the constructor for a savings account, correct? So then what I can do is I can say, you know, savings account equals new savings account. And I have to provide it with all these things up here. What does it say? The balance, the number, the owner, and now this strategy. So for the balance, I'll give it 1,000. The number will be number 1. The owner will be myself. What am I going to plug in for the strategy? Yeah, where is my strategy? I don't have one yet. I haven't made a strategy yet, right? A strategy is a class. So in order for me to use that class, what do I have to do? What do I have to do when I want to use an object? I have to make a new one. I have to create a new instance. Strategy is an object, right? It's being defined as a class. It is an object. So actually, I got a step ahead of myself. Before I create the account, I need to create the strategy that I want to use. So I'm going to say continuous strategy equals new continuous strategy. And then what does continuous strategy need to do its job? It needs the interest rate. That's all it needs. All that it needs. So I don't know what a good interest rate is. 0.1 is actually probably really high, but that's what I'm going to use. Why are you mad at me? Probably because I didn't save my stuff. I'm always forgetting to save my stuff. Let me try again. No? Still unhappy with me? I spelled it wrong. Well, I believe that for sure. Continue. I'm missing a U. Thank you. Thank you. All right, so now I have a continuous strategy. What's this called again in computer science lingo? It's called, well, I called the constructor, and the constructor creates an instance. Creates an instance. So then I just plug the instance in there. Okay? And let me create a second account. Let me create a second account using much the same technique. In fact, I'll just copy this over again. I'll create a non-continuous strategy for the second one using a similar technique. Oops. A non-continuous strategy needs a little bit more information, right? It needs the interest rate, but it also needs the number of periods. It's the number of periods. So I'll say, I don't know, 12. Yeah, I was going to use 12. I'm going to use 12. And I'll call this Doug's account 2. And I'm going to keep all the values the same as much as I can. I'll get a different account number. Let me pause here. I know I just went a little bit quickly. Let me pause here and show you what I've got. I created 2 strategies, a continuous strategy and a non-continuous strategy. I created 2 accounts, one that passes in the continuous strategy and one that passes in the non-continuous strategy. Here's a question for you. Here's a question for you. The type of this object is listed as a continuous strategy. The type of this object is listed as a non-continuous strategy. The type of the parameter that I pass into the constructor is listed as a compoundable. How the heck did I pull that off? Because it implements because both of these implement the compoundable interface, right? Because both of these implement that compoundable interface, that means I can treat them as compoundable objects. What's the name of that again? Polymorphism. We talked about that with inheritance last time. Works with interfaces too, right? Works with interfaces too. I can treat an object as the type of any of its interfaces or anything that it inherits from. That's polymorphism. Again, this is polymorphism. Hopefully you can see how polymorphism helps us here. When I pass these strategies in and I use these strategies to compound the interest, I don't know whether I'm doing it continuously or non-continuously. It doesn't matter, right? because I know they implement this interface, because I can treat them as a compoundable object using polymorphism, whether it's continuous or not doesn't matter. It just goes off and does its thing and gives me the value. So here's my continuous one. That's Doug's account dot compound interest. But maybe I should get the interest dot, Doug's account dot, well, okay. Getting ahead of myself again. Let me compound the interest first, separately, and then print out the results. Semicolon there. And then I'll just print out the balances of each. Doug's account 2. All right. So I just called the compound interest method on both. Let me change this to say non-continuous. And now I'll print out the balance for each. And I would expect them to be slightly different from one another since they've used two different techniques. Let me go ahead and run this guy and take a look. Run as Java application. So you see very slightly different. With such a small balance over a short time period, with a very low interest rate, I wouldn't expect to see them to be that much different. But they are different. So that illustrates that even though I treat them the same way, right? Down here, I treat them exactly the same way. From this point onwards, I can't tell which strategy is being used by which one. It doesn't matter. But I'm actually using two different strategies, even though I'm treating them in exactly the same way. That's a nice thing to be able to do. I feel like we covered a lot, so let me pause here and see if anybody has some questions. This is all I had about interfaces. So any interface-related questions before we do something else? Please don't hesitate to ask. I know this is tricky. Yeah. Sure. So yeah, so when should you use the strategy pattern? That's a great question. If there's ever more than one way to do something, I have the same behavior, but there's more than one way to do it, right? That's textbook strategy pattern. Create an interface that defines the behavior that you're doing, and then implement that interface using strategies and create, two different implementations of the same interface, or more. It doesn't have to be just two, right? Two or more implementations. We actually saw this a little bit earlier on. In fact, today's studio, just to give you an idea of how I asked you to use the strategy pattern in today's studio, goes all the way back to pset 2. I know how much you guys love pset 2. That was Caesar cipher, Legionnaire cipher. Those are two different ways of encoding strings. Two different strategies for encoding strings. So I ask you to take those two different strategies and use a strategy pattern to start doing that stuff. Okay? It's also going to be a great example of taking C code and porting it into Java code, which I think is a nice skill to be able to have, so you can see where they overlap, where they don't overlap. You'll realize that Java is a much easier language to code in than C. All that fun stuff. So yes, in fact, since we're on the topic, let me just mention that the strategy pattern is one of many defined design patterns. If I had another month or two to spend with you guys, that's what we'd be talking about, are other design patterns. That's what we'd spend our time talking about. Because you know the basics. You know interfaces, you know inheritance, you know how to create objects. Those are the basics of object-oriented programming in Java. From there, it's just a matter of how to design things efficiently. And so there's a whole set of prescribed design patterns that exist. I would highly encourage you to take a look at some of those. The strategy pattern is one frequently used design pattern. Any other questions about interfaces before we do something different, before we do something else? I will, of course, post this code once I'm finished as well. It'd be very useful when you're working on the studio. The other topic on the agenda for today is exceptions. So let's talk about exceptions a little bit. Somebody describe what an exception is in a sentence or two. What is an exception? Yeah. Not if it's right, but if it's wrong. And exceptions are used when stuff goes wrong. Exceptions are used when stuff goes wrong. I like that you called it a mini test. I like that. That's nice. When am I going to use exceptions? We already talked about a concept for checking when things go wrong called data validation. You did that with the menu system, for example. I know you did some of that stuff in the CS50 portion of the course as well. You did some data validation. What the heck's the difference between the data validation techniques that we've been using and exceptions? Why do we need another way of checking to see if things have gone wrong? Yeah? Right, so exceptions I think of as errors for programmers, data validation for other programmers, other people who might be using your code later on down the road. Data validation as you use it in the menu system, right, or other uses is for the users, So think about the difference there. If I throw an exception, I'm going to say something like, you gave me an index that's over the bounds of my array, or you gave me something that was a string. I was hoping you were going to give me something that was a double for this constructor, right? If I tell that to a user, somebody who's not a programmer, they're going to look at me and go, what? They're not going to know how to fix that problem. You guys know what constructors are. You guys know that indexes have to be within the bounds of an array. You guys understand different data types, right? Users, some of them might, most of them probably will not. So for the users, we use data validation. We don't bring everything to a screeching halt. We just say, you give us something bad, right? We can be a little bit more forceful about it with exceptions. So with that in mind, one of the more common exceptions that I like to use is an invalid argument exception. So I see a lot of times, in fact, somebody asked me this, I don't remember who it was, but somebody asked me just a few weeks back, what do we do for data validation on our constructors? What if I give you a negative balance? The bank's not going to let me open a bank account with a negative balance. I can't do that, right? Giving you a negative balance is a bad thing. Probably the same thing for an account number. You can't have a negative account number. It doesn't exist. That's not how it works. If this happens, if I call the constructor and I give you a negative balance, is that a user error? How do I know? How do I know? I'm gonna make the assertion that if I call the constructor with a negative balance, that's not a user error. But how do I know? Yeah. A user wouldn't call the constructor. A user is going to interact with what? The user interface. The user interface. So if the user gives me a bad value, I need to catch that on the interface level and say, oh, you gave me a negative value. Please give me a positive one, right? Give me a positive value. If I see that in the constructor, that means somewhere somebody's trying to create a savings account and they gave me a bad value somehow. They gave me a bum value. I don't know where it's coming from, right? Just wherever it happens to be used. They gave me a bad value. As a programmer, the programmers are the ones using the constructors. So what can I do then? I want to create something that checks the balance. In fact, I should probably do that. Here's another good inheritance question, right? You see, I take in the balance, and immediately I call super. What does that do again? It goes back to my base class, right? So really, I don't need to check it here. I could. I don't need to, though. I should probably check it in the base class, in my account class. So I'm going to go back to my account class and look at the constructor up here. And I see, okay, here's the balance. I want to check this balance and see if it's less than 0. That's simple. If balance is less than 0. If it is, what am I going to do? How do I activate an exception? I'm trying not to give away the answer. Throw. Throw is the word. Throw. What comes next? I have to say new, and then I have to specify the type of exception that I want to throw here. In this case, they gave me an argument that I don't like. They gave me a negative value, right? They gave me a negative value. So there's an appropriately named illegal argument exception. This is the same one I think I did in the video. So do data validation. This looks just like normal data validation, right? Looks like normal data validation, except now instead of asking them to try again, I'm not going to ask them to try again. I'm going to say, oh, you screwed up. You made a mistake. Right? So I throw this illegal argument exception. There are lots of different exception types. I don't know them all. This is a case where the documentation is going to be your friend. Documentation is going to help you choose the appropriate exception type. While we're on the topic of types of exceptions, actually, you can define your own exception types if you want to. Maybe there isn't an error that is specific to what happened, right? What you're looking for. You can create your own exceptions. The way to do so is to create a class that inherits from the exception class. So exception is a base class. Illegal argument exception inherits from the exception class, as do all exceptions. They all inherit from the exception base class. So if you want to create your own exceptions, you can. An exception is really just what? What is an exception? What is everything in Java? It's an object. Exception is an object. This new keyword is a dead giveaway, right? I'm calling the constructor for this exception and then throwing it. Okay. So then if I'm somebody that's using some code and I'm not entirely sure whether I'm doing it correctly, maybe I feel like there's a chance for something to go wrong. I feel like, I hope I'm using this correctly. I really want to use this correctly, but I still feel like maybe I'm not. Maybe at some point this might throw an exception. What would I do then? How would I account for that situation? I'm sorry? Yeah, I'm looking for something a little bit more specific. What kinds of code could I use to help me determine whether or not an exception has been thrown? The try-catch block. The try-catch block. That's exactly right. So I'm going to use a try-catch block. I'm going to use it to do some unit testing. I'm going to go to my account test. My account test is currently broken, probably because we changed the account last time. Let's see. Balance, number, owner, min balance. Oh, okay. So I'm missing a parameter. Let me fix that. Min balance of $50. Are you happy now? Okay, cool. I'm going to create a test to test my exception. I'll call it the test negative balance. And for this test to succeed, what I want to happen is for an exception to be thrown. I want to give this thing a negative balance, and then I want to see that that exception is thrown. That's what I'm testing for. I'm testing to make sure that my exception works, right? So what I want to do is create an account. But I'm going to give it a negative balance. So I gave it a negative balance. I expect this to throw an exception, but how do I tell whether an exception has been thrown? How do I handle that exception? How do I deal with it? What do I need to add to this? We know we know try catch is the answer, right? So what's the try and what's the catch? What is try for? Yeah. Yeah, it's kind of a test, right? So it's like, so what do I put in the try section? I put the stuff in the try section that I expect might go wrong. Maybe it will, maybe it won't. I'm a little unsure. I suspect that it might go wrong. So anything that I expect might throw an exception, I'm going to stick in a try statement. And then I say catch. What else do I need as part of my catch statement? I need a parameter here, exception. So in this case, so I started doing something that's actually kind of a bad thing. I just typed exception E. Exception, I just said, is the base class, right? Exception is the base class for all exceptions. So what exceptions am I going to be catching here? All of them. Every single one. Any exception that could ever possibly be thrown will be caught if I say exception E, because they all inherit from the exception base class. I really would like to be as specific as possible. So if there's something in particular that I'm concerned about, a particular exception, that's what I want to put here. In fact, I know that the exception that I'm looking for is an illegal, my spelling is just really bad today, arguments exception. I want to try to be as specific as I can. And then down here, right, at this point, I know I've succeeded. This is what I expect to happen, right? I just set it up so that if I give you a negative balance in my constructor, it's going to throw an illegal argument exception. So from a test case, this is a good thing. I think I could just type succeed. Will it recognize that? No, it won't. I forget what it is. I forget what method it is to just have it pass. Is it pass? No. It's not it either. Well, I can cheat and say assert true. This is a little ugly, but that's okay. True is definitely true. Without a doubt. Here's something that I know I didn't talk about in the video. If I want to, so maybe an exception was thrown, but it wasn't this one. Maybe something else was thrown. I can put another catch statement down here, and I can list a different type of an exception, right? So maybe for this one I'll say exception E, and now I'll say, fail, didn't throw right exception. And if I wanted to have a third catch statement, I could, or a fourth, or a fifth. Now, I've been using these in tests, both in the video and up here. I've been using these as part of my unit tests, and I think this is good practice, right? But I also want to make it clear that you can use try-catch anywhere. Anywhere that you think an exception might be thrown, you can use try-catch statement to handle that. Maybe there's a case where an exception is thrown, but you're able to fix the problem. I could use catch to catch the exception and then try something different, right? Try a different way that might fix the problem, or it might succeed that way. There are certain cases when I'm required to use try-catch. Those are called checked exceptions, where I don't have an option. I have to use try-catch around them. For things like a legal argument exception, those are unchecked exceptions, which means I don't have to use try-catch, but I can if I want to. But if I run this test, I would expect it to succeed. So let me try it out and see. Let me try it and see. And we're good. It passed. It passed. So what happened? I gave it a bum value on purpose. It threw this exception, but my catch statement caught it, which is exactly what I wanted. That was my expected behavior, so it passed the test. Those are the two big things with exceptions, try catch and then throwing them. when you need to do data validation. Are there any questions? Any questions? All right. If there aren't any questions for me right now, I'm going to go ahead and wrap it up then. I'll post this code online, and you can get started on the studio or keep working on the pset or whatever it is you are working on. Please let me know if you need any help. Thanks.